Hello guys, so welcome back to the channel. So today we're going to be looking at this network infrastructure lab that we have here. And within this lab, this is just a network simulation lab. And we have several single points of failure, like one router that's going to be connecting to different internet service providers. In the case where this router goes down, the whole network is down. So it's good to have that in mind as well. And we equally have one core switch as well, in case our core switch is down. Also, all network is down as well. So normally, depending on the environment you are in, there's possibilities to have two core switches for redundancy and equally two routers as well. And this lab is purely for networking. And also, we need to put in mind that there's no security, in-depth security within this infrastructure because we don't have a firewall. Actually, in production, you always want to have a firewall and key parameters put in place to make sure that the network is secure. So we're going to see how to implement this lab today, and we'll just have some explanations as to how the lab works. So we have two different internet service providers. Internet is expected to come through. Our core switch here is going to be running our SVIs, which is the switch virtual interface, and we have all our different um, VLANs here representing our different departments, and all of that is going to be routed at the level of the core switch. We are equally going to permit inter-VLAN routing possible through the SVIs at the level of our core switch. And also, we have a staff Wi-Fi here, and we equally have a guest Wi-Fi here. So it's just important for simulation to ensure that maybe staff Wi-Fi is actually segmented from guest Wi-Fi. So there's a whole different level of setup as to how Wi-Fi can be set up and implemented. But in this lab, if you get along and follow with the setup, following this TVT architecture, then you're going to be good to go. Where we have our core switch, moving to our distribution switches here, and also moving to our access switches, which we have at the bottom here, connecting our devices. So we'll learn several protocols as we go about this project. We'll see about things like setting up SVIs, equally things like STP, VTP, and the likes of that. So it's very important that we know that, and so we'll just go ahead and start up the lab then. So we'll just go to our router. I'll get to the router here. Hopefully it's ready for us to use. And when it's ready, we'll just set our router up, and as we go ahead, we're going to be explaining some key concepts here. So some of us might be familiar already, but some of us are not yet that familiar to how SVI work and how we anticipate for traffic to be able to leave from here to the internet and the likes of that. So let's assume that we have a particular user here, and this user is expected to reach the internet. So traffic is expected to get to this our switch here, and these two interfaces here, we expect them to be assigned to VLAN 10. And since they're in VLAN 10, this other interface here is expected to be trunked, so it can be able to carry trunk based traffic to this distribution switch here. So our distribution switch here is equally going to forward that based on how we set it up. You forward it to the core switch, and at the level of the core switch is going to be where the gateway of this device is going to be. So once it gets here, we need to also make sure that this our LACP switch is performing routing functionalities, and we're going to set a default route that's going to send traffic to our router here for destinations that it's not directly connected to. And once it gets to our router, our internet service provider, so since they are going to automatically assign an IP address to this our interface here, it's going to be DHCP based. Since they automatically assign an IP both here and here, then also they're equally going to give us a default route as well to them. So there's going to be a default route here going to our ISPs. So when that is done, we need to also understand that traffic is always twofold. There's always going to be a response to that particular request that was given out. So once the response comes in, it's going to hit our router, and this our router here is going to be performing NAT functionality. So we're going to set up PAT, that's port address translation. And we need to also tell this router that if it receives packets that are destined for these internal networks here, any of these, since it's not directly connected to them, we want it to forward it to this our core switch. This our core switch, since it's going to be running SVI, it is going to be directly connected to those networks, and how, when we are going to set it up, it's going to know how to forward packets to each of these our internal networks. So that's how we're going to make network connectivity true. So if you have this lab running and set up, you can equally set up your DHCP here, your DNS, Active Directory, to just practice these tips. And with that being done, you should be able to master some of these cool networking concepts. So with that being said, we're just going to go straight and see how to make the lab come alive. So moving to our router here, hopefully it should be ready by now. We'll just hit enable, and we'll go to the configuration terminal. Once we're here, I'll just try to bring it here so that we can all see together. So once we are here, hopefully it's visible. So once we are here, we'll just enter and configure our interfaces. So we'll start with the interfaces connected to ISP1. So we are going to get there and we'll do int gi0/1, and we'll do IP add. We can add the IP add to DHCP. We can give a description. Or we can just say ISP1. ISP1 link. And we'll give that description, we'll take no shutdown. So once we do that, the next thing is we want to move to our next interface. Also, since this is going to be our external interface, it will be good for us to set up NAT immediately. And for those who don't know how NAT works, we're just simply going to make this interface our IP NAT outside. This is our external facing interface. We'll set up IP NAT outside and IP NAT inside here, since it's going to be our internal network for network address translation. And then once we do that, the next thing that we are going to do is we'll create an access list, and that access list is going to permit what networks we want to be able to translate their traffic as they move out to the internet and the likes of that. So we'll create the access list, and then we are going to enforce it with path. So we'll do the IP NAT inside source. We'll put our access list, and then we're going to use the overload command to make sure that path is enabled on our respective interfaces. So we need to make sure that happens, and we are also going to create our routes to our internal networks. So it's good for us to have that in mind. So having that done, we are just going to put the IP NAT outside here. You do that and you hit enter. So once that is done, we'll move to our next interface, int gi0/2. We'll call it do IP add DHCP IP NAT outside. We'll give a description, and the description will be linked to ISP. ISP2. So we can give a description like that, and take no shutdown as well to make that interface come alive. So having that been done, I'll hit exit here. We'll enter our next interface, int, and we'll give in the IP address which is on our design here to this interface, int gi0/0, and we'll put our IP address and we'll put our subname marks. Put our CIDR, we'll make sure that it matches. So once we do that, the next thing is we want to do the IP NAT inside, which is important. We want to do the IP NAT inside. And once we do that, we're equally going to take the no shutdown. Okay, equally give a description as well. can give a description, and we're going to say internal, we'll just say LAN, for instance. So having that been done, I'll take exit here. So having created our interfaces and actually set up NAT inside and outside, we'll create an access list. We'll say access list 1, and we are going to say permit whatever network traffic that begins with 192.168.0.0. Instead of the subnet mask, we are going to put the wildcard, because access list works with the wildcard, which is actually the reverse of the subnet mask. We are going to put it there as 0.0.255.255. So we'll put that there, and we are going to hit enter. So after doing that, the next thing that we want to do is we want to enforce our NAT now to be available. So to enforce the NAT now, we are going to enforce it on our ISP1, that's MTN here. So we'll just take the IP NAT inside source list 1. We'll put the list, then we'll use the numbered access list. So put list 1, which has our permissions that we are networks that we want to permit within that. And we'll put the interface, and we'll put our external facing interface linked to MTN gi0/1, and that command is not complete. We need to put overload. Hit enter and put overload here. So having that being done, the next thing that we'll have to then do is we need to create a route here, because if you check, for instance, the current routes that are in this our router, if we take do show IP route, if we take the do show IP route command, we realize that we can clearly see that we already have a default route here, and it's pointing to our ISP here from MTN. So that's good, but we need equally to tell this route that in case it receives packets that are going to our internal networks, you should forward it to this our core switch. If not, packets from our internal networks are going to be dropped. So to do that, we'll just create a route, which is going to be IP route. The destination is 192.168.0.0 with the subnet marks of 255.255.255.0. So the 0.0, since we are doing some summarization, should forward it to this other. He has to forward it to this our core switch here, and the IP address which is going to be on this interface is 192.168. Just put it there, 192.2, and that's what we need. You hit enter there. And someone might ask, why are we using just 192.168 for all these are internal networks here? That's just simply because if you look closely as to how the IP plan is set up for our internal environment, all these are different departments here. They have their network beginning with 192.168. So what makes the networks different is just at the level of the third octet, we'll have 10, 192.168.20, 192.168.30, 40, and so on and so forth. So that's what just makes it to be that way. And having that in mind, next thing that we'll have to then do is we need to be able to get along to set up our core switch. Then after that, because that's the main thing we need that we have just done here. So within here, we're just summarizing all the routes as necessary. So after doing all that, the next thing that we'll have to do is we need to move now to our core switch, and within our core switch, we'll set it up and then see how to make things work properly. So with that being said, let's just go straight and see how to make it work. Then I'm just going to save the configurations that we have currently done at the level of our core switch, of our router rather. We can give it the host name. I will just say router, and I'll just save our configurations. So we save the configurations of our router here, and we're just going to move to our core switch here. So within our core switch, if we realize that our key protocols that we're going to set up here. So now, since this core switch is going to be running SVI, that's the switch virtual interface that's going to permit inter-VLAN routing possible, we'll just set it up so that it works properly and the likes of that. And once that is done, then we'll see how to test for connectivity as well. So following the setup we have here, we'll have our distribution point here, our core, and our access here. So this is the 3-tier architecture that we are trying to deploy. And once that is ready, we'll see how to make it work. So within our core switch, the key things we'll do, we are equally going to create all our VLANs available there. And in order to prevent us creating those same VLANs on all other switches, what we are going to do is we'll set up VTP, which stands for the VLAN trunking protocol. And that protocol is going to help us to synchronize all our VLANs which we created at the level of our core switch to be made available at the level of our access and distribution switches. VLANs available at the level of the core switch does not necessarily mean that devices are connected to it. Until you make a port to be an access port to that VLAN, then devices can connect to that VLAN. But it's always good practice to make the VLANs available on all switches. So with that being said, we'll just go straight to our core switch here, which I'm already in. And I'll hit enable. We'll go to our configuration terminal. And once we are here, I'm just going to give it the host name as core switch. So after giving the host name, we'll just make this switch to start performing layer 3 functionalities. We'll type IP routing. And after typing IP routing, the next thing we are also going to do is we'll create our VLANs here. So in this environment, we'll have several VLANs like VLAN 10, which is for users, the HR, the sales, the staff Wi-Fi, basement, Internet of Things, and research and development, the guest Wi-Fi, and so on. And we equally have our management network here. So these are management VLAN, and this management VLAN is going to be used for managing our different environments, probably setting up SSH or remote access. You don't want to be going to all the switches manually from one point. You want to be able to manage them. So it's good if they have their own isolated network. And why you need VLANs is equally for security mechanisms. You don't just want one network to be running the whole environment. So it's a great security best practice to make sure that our environment is segmented. So after doing IP routing, the next thing is we'll just create our VLANs. There are several VLANs here. And if you have the same environment, you can create all the VLANs. I'll just create like 4 VLANs here to see how we can be able to make it work. But the same concept applies for all. So to do that, I'll just hit, we'll just create VLAN 10. And I'll give it a name like users. Create VLAN 20. We'll give it a name, and the name that we are going to give it is HR. We'll create VLAN 30. We'll give it a name, sales. We're equally going to create VLAN 99, for instance, and we'll give it a name as MGMT. So we'll give this name as well. So after doing all that, what we want to do is we want to try to make sure that all these VLANs we have created here are made available at the level of our different switches below. So we need to set up VTP. So right now all our VLANs are created, and if you look closely, if you use the command do show something like VLAN brief, you will see that we have all our VLANs there, but all our ports are still connected to the default VLAN. That's the default VLAN 1. You see all our ports are connected there. So normally in the production environment, you want to always make sure that you change the native VLAN, because now the native VLAN is VLAN 1. You want to change this native VLAN so that it's a security mechanism as well. In case one gets into your network, they don't just have access to that native VLAN there. So for this particular lab, we'll keep the defaults, but I'll show us how you can be able to change the native VLAN so you can go a little bit fast. It's good to always change that. And also, let me hit enter here. I'll just hit exit. I didn't see VLAN 99. Let me hit exit, and then we are going to check again. Do show VLAN brief. So if we check again, yes, we have our VLAN 99 available there. So now within our environment that we have now, if we look here, we're supposed to set up this IP address on this interface. That's Giga Ethernet 0/2. So we'll just go ahead and do that there. So we'll do the int Giga Ethernet 0/2. We'll enter. And once that is done, the next thing we'll have to do is, since it's a switch port, we need to make it not to be a switch port. So take no switch port, and then we can then add an IP on it. So take IP add. So once we do IP add, we'll put in the IP address which we designed on our implementation here, which is 192.168.254.2, and you put your subnet mask 255.255.252/30. So hit enter there, and we'll take no shutdown as well. You can equally give it a description. And give a description like link to router. So I'm going to hit exit here. And also within this our core switch, we'll set up a default route to forward all packets which it's not directly connected to. If it's going to a destination that is not directly connected to, we want it to forward it to our edge router at the top. So we'll set up here IP route, and IP route, if the destination is 0.0.0.0 with a subnet mask of 0.0.0, forward it to 192.168.254.1. Hit enter there, and that is done already. So with that being done, the next thing is we need to set up VTP now. So I've created our VLANs, we need to set up VTP. So to set VTP up, by default, most switches, the VTP mode is set for them to be the server. So I'm just going to say VTP mode. Here I'll just say server, even though it's already the server, and take VTP domain. We need to give it a domain. I'll put Dubro. I'll just put Dubro, and I'll just give it. I'll just say, and I'll put the next one. VTP password. For the VTP password, you can put anything. You can put something complex, but in this our simple environment, I'll put Dubro 123. So having that in mind, all our clients, for them to be able to receive this route, we must put these parameters but set them to clients on all the different switches so that they get all the VLANs. We don't have to manually go and create all these VLANs all over again. So that's how we set VTP up. Now going to the next part, setting up SVIs for this core switch to play the core role as the gateway if packets destined from one VLAN want to move to another VLAN. So to set that up, what we then need to do is we need to move to every VLAN. I'll go to int VLAN 10, for instance. We'll enter the interface and we'll give it an IP. So put IP add. So put IP add 192.168.10.1. That's for VLAN 10. But I'll give it an IP here so that this will be their gateway. .0 here. You hit enter. And you take no shutdown as well. So after that is done, the next thing is we'll do same for the next VLAN. We'll do int VLAN 20. We hit enter, and we'll take IP add For VLAN 22, do same 192.168.20.1. Put our subnet marks. Read enter and we'll take no shutdown. The same for VLAN 30. So we'll do the int VLAN 30 and we'll take IP add. So we'll take IP add 192.168.30.1, 255.255.255.0. So we'll do that and hit enter as well. And we'll take no shutdown. So we created this, and I remember also created VLAN 99. We'll do same for VLAN 99. We'll do int VLAN 99. Hit enter, IP add, put 192.168.99.1. Put our subnet marks and hit enter there. So I will just type no shutdown as well there. So having that been done, we're going to now realize that if we check, for instance, using do show IP interface brief, we realize that we actually did set this IP address, which is this, and we have our different VLANs here which will perform the SVI functionalities, and all of them are down. And the reason why they are down is because these are ports here are not yet chunked, and that is fine. So now we have our server here, and this server is directly connected to the core switch. So since this server is directly connected to the core switch, so this port on the core switch is an access port. So we need to make sure that we set up that port, since we're at the level of our core switch here, to be an access switch, to be an access port for VLAN 99. So it's equally giga ethernet 1/0. So enter the interface int gi 1/0, and to make that port to really belong to VLAN 99, we'll do the switch port mode access and switch port access VLAN 99. And you can equally set up something like the spanning tree to port fast, because what port fast actually does is that, as regards to spanning tree, because spanning tree, that's the STP, we actually use spanning tree within networks to ensure that we stop these loops. And most switches that comes today actually have STP implemented, but you can customize it more to suit your needs. And the key thing we're supposed to note with the port fast, as I was mentioning, or with STP, is that, for instance, within networks we have some things like broadcasts. Let's say a particular device within our environment, let's say a particular device, let's say this is a device here, needs an IP address. So it's going to send broadcast signals to all devices that is connected, to saying that, oh, it needs an IP address, if it was set to receive an IP address through DHCP. So when you float those broadcasts, they are going to move to our distribution, move to the access switch here, and equally get to this our distribution switch. And if STP is not implemented, this distribution switch will forward it to this core switch, since it's a broadcast, and this distribution switch will also forward it to this other distribution switch here. The distribution switch will also forward it back to the core switch, and the core switch will forward it back here, and we'll have this loop. So the broadcast storms that we could have within networks, if STP is not there, that could greatly impact the performance of the network environment. So it's always good to ensure that spanning tree is configured. Now, at the level of ports, you want to set up spanning tree to port fast at the level of your access port, because sometimes it improves latency in the network, because it decreases latency rather, because with spanning tree port fast, what it simply does is that it makes sure that any device that connects to this port this switch does not take time to try to identify whether that device is another switch or is an endpoint device. So we're just telling the switch that whenever any device connects to this port, just know it's an endpoint device. It's not necessarily another switch, because normally if it's another switch, the core switch or any other switch that's an access switch, a layer 2 switch rather, is going to try to see how to is going to use some few seconds to try to identify if the other device is another switch. So we're trying to avoid those little delays to make sure that the forwarding mode is being reached immediately for that particular switch there. So we'll just do that immediately, and to do that, we'll just give it spanning tree, and we'll set the port fast, and you hit enter there. So, and the port path interface is not supposed to be a strong port. So I'll just take no shutdown on that interface to keep everything smooth there at the level of our core switch. So now, with that being done, the next thing that we're supposed to do is I'm going to exit this, and we have set VTP already. We have equally set up our SVI interfaces already. And the next thing to do is, with what we have here in the environment, I'll expand this our screen so that we can all see clearly. With what we currently have here at the moment, we can clearly see that in this environment here, we're trying to set up EtherChannel between these interfaces of this core switch, these two interfaces and equally these interfaces and this here. So now the whole purpose for EtherChannel here is to actually to increase bandwidth. We're trying to bundle up two interfaces to make sure that the speed increases there. So it's not mandatory to have it all set up this way, but within your design you might want to put that if it permits. So we'll see how to do that. And there are different types. There's SPARC and there's LAC. One is Cisco proprietary and the other one is non-Cisco proprietary. So it's always good to go with that which is non-Cisco proprietary, or depending on your environment. If you work always with Cisco devices, you can go with the one that is Cisco proprietary. So we'll just try to set that up and then we'll see how it works. And since these are SVI set up here, these interfaces of our distribution switch here have to be chunked. These two interfaces here would be chunked as well. And also this interface of our access switch is going to be chunked here. Before going to that, I'd just like to explain briefly as to what is really happening. Let's say if let's say if a device within this network here, if a device within this network wants to talk to another device within, let's say, this other network, what happens? So since this port here will make it to belong to VLAN 10, packets will normally be forwarded here, and the packets will be given an ID of VLAN 10. So as it moves to the top, this interface here is going to be chunked since this particular switch is not directly connected to this device. You will not know how to forward it. So trunking helps it to be able to forward multiple VLAN traffic towards that interface there. So since it's trunk, it's going to be forwarded to this particular core switch here. On this particular interfaces, it's not going to move to this other interface because we'll allow just the respective VLANs as necessary. So it's going to be pushed to the top here since all VLANs will be permitted. Once it gets to the top, the core switch will look at it and say that, oh, I see this man is going, the destination here is going to another network, and I'm the gateway, and I'm also directly connected to that network. So since it's directly connected to it, by virtue of the SVI interface there, it forwards it to that particular interface using the trunk port links that must have been done here. So you can trunk it downwards. So once it goes downwards here, this other distribution switch, these interfaces must also have been trunked and permitting the respective VLANs that they are connecting to. So with this, it gets down to our research and development VLAN here. And from this access switch here, since this access switch knows how to learn the destinations of different devices based on their MAC addresses, it will know how to contact these devices here. And also the response follows the same pattern where it's going to be able to come back to this access switch. From the access switch, this interface is strong, so it goes back to the distribution. From the distribution as well, it gets to the core switch, and from the core switch to it gets down again here and the likes of that. So the same pattern works that way. So it's good to have that flow. Now this is when a device from one VLAN wants to talk to a device in another VLAN. Now if a device in this VLAN wants to talk to this other device, yes, because they're connected to this switch, the packet normally moves to this access switch and then to this its destination here. But let's say if you want to talk, if a device in this VLAN wants to talk, that's this network wants to talk to another device of this same network, but the network is in this other environment. Let's say here, it's just an example. The same thing applies, but without SVIs. Now, this is just purely layer 2 based packet flow. So using the trunking process that we just explained, the same thing applies as well. So it's good to know the differences when you're working with switches. But going back to our configurations that we had, we are going to move to our core switch that's here and continue the process of setting up our EtherChannel as we just explained. And once we do that, we perform the trunking so that connectivity goes smoothly. So now to do that, we're just going to move to our core switch and then we'll look at those our respective interfaces that we need to trunk. So before doing the trunking, I'll just enter first of all these two interfaces. These are the two interfaces here. These are our two interfaces. I'll just set them here and we'll see how to make that work. So with that being said, here we'll just enter both of them at the same time. So we'll do int range giga ethernet. I'll just gi that's 0/3 0/3 and I'll put a comma. Gi that's 0/0 and I'll hit enter. So once we do that, then I'm just going to now put channel. We can put a channel group and put 1. So since we're trying to set up the first port channel here, I think from our design we'll give it port channel 10. We'll just give it the same name, port channel group 10. Hit enter. Put mode. So now there are different types of modes here depending on what you want to work with. If you're using the Cisco proprietary for EtherChannel, then let's say if you're using things like PAC or LAC, we'll have the active, and then we'll have the auto, and we equally have desirable as well. So it's always good to just set all of them to, if you're using, depending on what you're using, I'll just set it to active. It's good for them to be in the active state. If you want to understand what active means and what, let's say, desirable means, for active, it just simply means that it's just going to be seeking all the time to make the connection with the other party. Because when we say the other party here, this is going to be the other switch that has to establish that EtherChannel mode with. So if you normally set the channel group 1 mode active here, on this side, we can equally set the same thing and just use passive. Or we can use desirable or auto, depending on what we are using. But if you set it to desirable and on the other side you use desirable, then all of them will keep waiting for someone else to initiate that particular connection to happen, and the channel group is never going to be established. So it's good to have that in mind. So with channel group 10 mode active, you can hit enter there. It's going to create a port channel group by default, and I'll just do that. Let's see, and it's going to be down. So you're just going to create a virtual interface as well. So while it's currently using lab, since you set to active and it's not enabled yet, so wait for it from the remote side. When it's enabled, then it's going to come up. So now going back here, I'm just going to trunk this interface as well before moving to the next side. So I'll do switch port. These two interfaces, I'll trunk them. Since I did the interface range, that means these two interfaces, we're setting it up on them as well. So I'll do switch port trunk encapsulation dot 1q, read enter, and switch port. Let's see what we have here. Can cannot bundle that with compatibility. Okay, let's see. Let me hit enter here and see. Yes, and I'll do switch port mode trunk here. So I'm going to trunk these two interfaces. So I've shrunk the two interfaces, and let's see what we have. Yes, we have shrunk those two interfaces there, and I would use the do show IP interface brief. We are going to see our port channel at the bottom as well. This is our port channel 10 here. So this port channel 10, this is our interface here like this. We need to also trunk this interface because these are virtual interface that has been bundled as well to increase bandwidth speed between that link. So I'm just going to do int port channel. We'll do the, I think I'm the, let me exit here. We'll do int port channel port channel 10, and here we're just going to do the switch port mode trunk. Switch port, we'll do the encap first, encapsulation. Switch port switch port trunk encapsulation .1 queue. We hit enter on that. I'll do the switch port mode trunk. We'll do that there as well. So we trunk that interface, and it's currently giving us this lab currently not enabled on the remote port. It's because we have not set it up. When we won't get there, we'll set it up as well. So I just want to do that here, and I'll do the same thing for this other two interface here. This G0/1 and 1/3 pointing down here, but now it's going to be port channel group 20 based on our design here. So I'll just enter I'll exit this interface, and I'll do int range giga. I think I need let's go back to our int port channel 10. I just want to take no shutdown there. To bring it up, I'll hit exit, and here I'll do the int range. We'll enter those other two interfaces that I mentioned. We'll do int range, and within this range is going to be G0/1 and 1/3. So we'll do that int range G0/1, put a comma, and G1/3. That's giga Ethernet. We hit enter. So we'll do the same thing here, channel group 20 mode set to active. We'll just set active everywhere. There's no problem with that. And once we do that, we have already now created the port channel 20. So having that in mind, the next thing we want to do is that we want to try to trunk these two interfaces as well. So I'll just do the switch port trunk encapsulation .1 cure. I'll hit enter, and I equally do switch port. Okay, no problem. That will be suspended. Noted. Equally do switch port mode trunk, and here I'll take no shutdown. We'll take no shot. So I hit exit, and if we take do show IP interface brief, we realize that we have our second port channel that is there 20. Right. So now we'll do the same thing here. We'll do int port dash channel 20. We enter port channel 20, we hit enter. So while we're there now, we're then going to trunk this interface as well. So do switch port trunk encap.1 cure. We hit enter and then switch port mode trunk. So now when you just do switch port mode trunk, you're just allowing all VLAN access to that particular through that interface. But normally sometimes you want to do some restrictions like permit just the various VLANs that you need to pass through that particular interface to the next destination. So but in this environment, we'll keep the defaults as they are there. So I'll hit enter here. We'll keep getting these errors from both interfaces till we set it up properly on the other side here. So having that been done, we are already done with the level of our core switch. I just wanted us to set things up at the level of our core switch and be done. So I've bundled these two interfaces up here and bundled it up here. We need to come to our distribution switch here as well and bundle this up too. And also on this other distribution switch, bundle this up as well so that things go smoothly. So now we'll just go to our next distribution switch one. I'll just double click on it here. And I'll switch it to this side of the screen. I'll hit enter here. Use enable configuration terminal. Here I'll just give it the host name. I'll give it the host name. Let me switch it here. I'll give it the host name as dist switch 1. And while we're here, what we want to do is, first thing is we want to go to int range. We'll take our two interfaces, that is G1/TV and G0/0. So take G1/TV and separated by comma G1/0. So once we do that, then we now G0/0 rather. Make sure it matches what is on your design. So take G0/0. And once we do that, we do the switch port. We'll start with the channel group. Channel group on this side was 10, so make sure you maintain the number. I'll put the mode to active as well. We'll do that. And then also we need to trunk the port channel group, the port channel 10 interface, that our virtual interface here, since that was what was done on the other side. So now we're just going to move to that, and I'll just trunk this interface as well. These two interfaces, I'll do switch port mode trunk. Before taking trunk, it's good for us to do encap.1 cure. Switch port trunk encapsulation.1 cure. And we'll do switch port mode trunk. So we'll do that. And once that is done, we can see that our interface port channel 10 changed state to up now, like this. So once that is done, the next thing is I'll just exit. I'll exit this interface, and then I'm going to, if you take do show IP interface brief to check our virtual interface that has been created, that is port channel 10. It's the same thing. I'm just going to enter there, and while we are there, I'll do int VLAN. Sorry, we'll do int port channel 10. And once we are there, I'll just trunk it as well. Switch port trunk encap.1 cure. And when that is done, the next thing that we are going to do is we are going to then trunk the port, switch port mode trunk. So that should be done. I'll take no shutdown on this interface as well, and I'll just exit it. And after exiting, we'll just take the do show EtherChannel summary. So check the summary, and we're going to see yes, slabs up port channel group. That is okay. Yes, that is good. 0/0 and that. So now on this other distribution, before leaving this distribution switch, I would just like us to let's check if our VLANs are available on this particular. Let's set up VTP here to be the client, so you can be able to receive the VLANs that were created at the level of the core switch. So here we'll just do VTP mode. We'll set it now to client, and here you hit enter. We take VTP domain, we'll put double, and equally VTP password. The VTP password, we'll put the same password we use, double 123. We'll do that, and with that, we'll give some time for us to be able to get the VLANs available from the core switch to this distribution switch. So we'll just check the VLANs here. Do show VLAN brief. Okay, they're not yet here. Just give it some time and we'll find them all available here. So now we're going to move to our next distribution. But before moving to that, it'd be good for us to trunk these other interfaces coming down to these respective switches. But we'll do that when our our VLANs have been synchronized to this distribution switch. So I'm going to go then to our distribution switch tool. I'll double click on distribution switch tool, and once we are there, we'll hit enter there. Enable conf t, and we'll just do the switch port. Sorry, here we're just going to give it the host name, dist switch 2, and we'll do the int range, because now on this other side, now what we're trying to do is we want to try to see that these two interfaces they match the port channel that was set on the other side. So here we'll just give the host name, and we did that already. We'll do the int range, and the two interfaces here is G0/0, comma, and we have G1/2. I'll hit enter there, and we'll do channel group. Here should be 20, and the mode we'll set to active. We hit enter. So once that is done, I'll just trunk these two interfaces as well. I'll do switch port mode, so switch port encapsulation, switch port trunk encapsulation .1 kill, and we'll do switch port mode trunk, and I'll take no shutdown as well. So I'll exit this, and then we're going to go to our port channel 20 interface that has been created. So we'll do the int, enter that interface, port channel 20, and I'll just take no, just switch port trunk encapsulation .1 cure, and we'll do the switch port mode trunk. So we'll do that, and after doing that, here we'll take next. I'll take no shot as well, and I'll take exit here. So once that is done, then we should be good to go. So we are also going to set up VTP here as well on our distribution switch tool. So give VTP mode, we'll set it to client, and VTP domain, we'll set it to double, and after that is done, we'll take VTP password, we'll set it to double 1, 2, 3. And with that being done, we should check to see if our VLANs are appearing on our different environments. I'll just take do show VLAN brief, and you can see that on our distribution switch 1, we never created the VLANs here, and they are all here now. Also on our distribution switch 2, it will give you some time, and I'll just do int do show VLAN brief. You see, it's not yet here, but you give it some time, it's going to appear here as well. So just to check on, if we go to our core switch here, I'll click here to go back to our core switch, and I'll hit enter. So once we are here, if you hit enable, by the way, it's good to reset up passwords as well, and you can set up the privilege level, secrets, and equally set up SSH as well. It should be a standard where you set up SSH on all your networking devices so that you can access them remotely and equally for security. And several protocols you can use to implement security, or let's say access to your devices, using things like radios and tacacs and other methods. It's good to use those methods as well. So within this environment here now, on the core switch, I'll just take the show EtherChannel summary to see if everything is done. Yes, at the level of the core switch, we'll have this 2, which is fine, and that is good, like that. So what we have just done now, you can do the same thing within these 2 switches here. You can do the same thing there. It's quite fine as well, as long as you understand what is happening. So I think maybe we should just do that, or yeah, that's for channel 1. I'll just do that right away on our distribution switch 1. I'll just bundle that up so we can move ahead to the next thing. So on this distribution switch 1 here, I'll just do the int range, and I'll put G1/1. I'll put a comma, and G, I think since it's from 1/1 to 1/2, we can just colon all of them together, 1/1 to 1/2. We hit enter, and I'll just put channel group. We'll put channel group 1. We'll just put 1 based on what is on our design, and then we'll put the mode to active. So it has created that. Hit enter, and I'll do the switch port trunk encapsulation.1 cure. We'll enter that, and once we do that, we'll do the switch port mode trunk. So once that is done, I'll take no shot, and I'm also going to exit this. I'm going to do the int to our virtual interface that was created, import channel 1. So once we do that, we'll take import channel 1, and once we are there, I'll take switch port trunk encapsulation.1 cure, and I'll do switch port mode trunk, and yes, and I'll take no shutdown as well. So take no shutdown, and now here I'll just take this is the distribution switch 1. I'm going to move to distribution switch 2 now on this side here, distribution switch 2. Following these 2 other interfaces here, we'll do the same thing, int range giga ethernet dash 1/0, from 1/0 to 1. So I'll hit enter there, and once that is done, then the next thing we'll have to do, as usual, we'll do the channel group, maintain the same number you used on the other side, group 1. We take mode channel group 1 mode will put active as well, and then I'll do switch port trunk encapsulation dot one cure, and we'll do switch port mode trunk. I'll take no short, take no shutdown, and I'll exit this. So once I exit this, the next thing is we're going to do the int range, int interface, the port channel 1 is the virtual interface that was created, port channel 1, and then I'll just do switch port mode trunk, no, switch port trunk encapsulation dot one cure. They'll take switch port mode trunk. So trunk the interface. So once that is done, I'll just take no shutdown here, and if we take do show IP interface brief, should be able to see that now the interfaces are all up, and those are our two interfaces that we created. And if you also take here do show EtherChannel do show EtherChannel, let me exit this mode. Do show EtherChannel summary. Hit enter there, we'll find that yes, this is for port 1, and the same thing should be for port 2 as well. If you take, see everything is up, do show EtherChannel. Let me exit this interface, exit, do show EtherChannel summary. We see clearly here that we have lab, and everything is up and it's all fine. Two interfaces and our port interfaces, the port channel. So that's the group, and everything looks okay for the whole setup here. And also let's check for distribution switch 1. We set up VTP here to be the client. We saw that the VLANs are available on distribution switch 2. Let's check here and see if the VLANs are available as well. If we check here and use, for instance, VTP do show VLAN brief, yes, all our VLANs are also here, and that's good as well. Now going downwards, I'll come back to our distribution switch 1. Since we created 3 VLANs, what I'm going to do on these 3 VLANs is the same thing that you need to do on all the other VLANs as well, on all the other links going to all other access switches from this distribution switch here. So to make that happen, what we are going to do is I'll enter this particular interface here. I'm on distribution switch 1. I'll do int gi0/. I'll just trunk all the interfaces at once, or rather let's just go manually, it's still fine, it's not really long. So in g0/1, I'll hit enter there, and I'll do switch port trunk encapsulation dot one cure. I hit enter, and I'll do switch port mode trunk, and here, and I'll do switch port trunk allowed VLANs, and the allowed VLANs here will just be for VLAN 10. So now this is equally important as well. I'll hit enter here. You can allow all VLAN traffic, is good, but at least for security purposes, it's just good to, since this link is actually just going down straight to VLAN 10, it's good to just permit VLAN 10 traffic to go down through this link, or to be trunked. Once traffic is about to be sent to this switch here, just VLAN 10 traffic should go down, not other VLAN based traffic should go through that. So we'll do that, and we'll take no short. That's all we need to do. We'll enter this next interface here of this switch, that's int gi0/2. Hit enter, and I'll just use the up arrow key to just do the switch port encap.1 cure, and then I'll do this. We'll use this one, switch port mode trunk, and then we'll use the allowed VLAN, this should be 20. We hit enter. I'm using the up arrow keys of the keyboard, and we should here take no shutdown as well. So I'll do the next thing. I'll do int gi0/3, and I'll hit enter here. And once that is done, here I'm just going to put in int VLAN. Here I'm just going to put the int VLAN. Sorry, we'll do the I've already entered that interface with the switch port. Let me use the up arrow key so it can be faster. Switch port trunk encapsulation.1kill. So they'll do switch port mode trunk, and they will do the switch port trunk allowed VLAN. So we'll take 30, and then we'll take no shutdown as well. So do that, and that's the same thing you need to do for all the other VLANs. And here you do the same thing here, and your guest Wi-Fi, if you have an access point, that access point will be connected here, and signals will be broadcasted to individuals. Following another network for setting up is the individuals will have a different network IP address, because you need to always set up your access point to broadcast signals. But for them to reach the internet, you always go back through this same VLAN tag that we are going to assign here at the level of our distribution switch and so on. So, and this port here will be an access port. This is not going to be a trunk port, because you want this device here, this access point, to belong to a specific VLAN, so you can do it from here directly, since all the VLANs are now available on this distribution switch here. So this access point is going to belong to VLAN 10. Or if you have another switch here where your access points will be connected to, fine, but you can connect your access point here as well. So for the purpose of this lab, not to make it too lengthy, we'll just set up these three VLANs and our management VLANs that we set. But the same process applies to you setting up everything here. And even with the setup and with what we have just done here with this, we're setting up these three interfaces to trunk. If you do the same thing here and do what we are also going to do with our access switches, you're going to realize that you have the ability to be able, let's say if a device here is in VLAN 30 or in VLAN 20, it can equally be able to communicate to another device here in that same VLAN. If a device connects here, and let's say we set up this environment here to be let's say VLAN 30, we'll make this device to belong to a VLAN 30 VLAN, then traffic from here following purely layer 2 setups is going to be able to get to this particular device like that. So if it's in a different VLAN, inter-VLAN routing with our SVI will make that happen. So it's good to have that in mind. So now, with that being done, the next thing that we want to try here to do is we are going to now move to our access switches. So the distribution switches, we are all good. So I'm just going to save what we have done there with the do write memory. And also on our distribution switch one here, I'll save that with the do write memory. So now going out to our access switch, I'll just come to our access switch. Within our access switch, all we need to just simply do at the level of all our access switches is we need to make sure that these two interfaces here for this, because of this lab environment, these are going to be the access port, and then here is going to be our trunk port. Access, trunk, here. Access and trunk here. Because where you set up an access port, that's what actually makes devices connected to that port to belong to VLAN 10 or 20 or 30. The creation of the VLAN is good, but the assignment of the VLANs to a particular port then makes it restrictive. So it's good to do it that way. So having that in mind, we are just going to go straight then to our access switch one here. I'll come there and we're just going to perform exactly what we said. So we enter here, I'll just hit enable, go to our configuration terminal, give it a host name as just say access1, access1, and then I'll just enter these two interfaces that I want to give access. So we'll do int range, and within that range is going to be G0/1, G0/2. I think it's 1 to 2. Okay, no problem. So while you are before doing this, we cannot give access when the VLANs are not yet created. It's not good for us to do that yet for now. So I'm just going to exit this first. Because if we look inside here, if we take do show, let's see, maybe we'll have the VLAN ready. We take show VLAN brief, do show VLAN brief. We don't yet have the different VLANs available here. So we'll set up this particular interface here for chunking first, and we'll set up VTP here as well. So we'll do int gi0/0, and we'll do switch port trunk encapsulation.1q and switch port mode trunk here, and we'll do switch port trunk allowed VLAN, and we'll put 10 here since that's the only VLAN traffic we really want to be allowed to go out. In fact, only VLAN will be made access there. Hit enter, take no shutdown as well here. So I hit exit, and they will set up this course, this switch here to be a VTP client. So the same thing we did before, VTP mode, we'll take client, and VTP domain, give the same domain dubro, and once we do that, we take VTP password and set our password to dubro. The same password is used at the level of the server, dubro123. So we'll do that, and once that is done, we'll give it some time. I'll just take do show IP interface. Sorry, take the do show VLAN brief. So our VLANs are not here. We'll give it some time as well. It should be available too. We'll come to this our other switch here, and we'll just do same while waiting for the VLANs to be synchronized from the core switch right down to the access switches. Enable conft, give the host name, and our host name here is going to be access. I should give access to, and here I'll do int gi0/0, and we'll do the switch port trunk encapsulation.1q. Then we'll do the switch port mode trunk, and then we'll do the switch port trunk allow VLAN, and take 20. I'll take no shot. We'll set this up as well to be VTP client, VTP mode, take client. It's inside another interface here. Just hit enter. VTP mode client, and take VTP domain, take dubro. VTP domain will take dubro, and VTP password will maintain what we had before, dubro123. We hit enter there. So now with that, we'll also give some time so you can be able to pick up the IP address, so with the different VLANs created at the level of the server. We'll come to here our sales and do the same thing. I'll be a little bit fast. So we'll give that, and then once that is done, we'll then do the int gi0/0, and we'll do the switch port trunk encapsulation.1q, switch port mode trunk, and then switch port trunk allowed VLAN. We'll put VLAN 30 in this case, And when that is done as well, we are going to now move to protect no shutdown. And once we do that, the next thing that we need to do is set up this as well to be a VTP client. So take VTP mode client, VTP domain, I take Dobro, and VTP password Dobro 150. So that's it for now, and we are good to go for now. So having that in mind, everything here seems okay. So if we'll just go back to our access switch 1 here, come back there, and I'll check if we have our VLANs. I'll just use the okay. Do show VLAN brief are not yet available there. So just give it some time so you can be able to come up. Take do show VTP status. Okay, so it's set to be the client. And just take it one more time again. All right, so just give some time. All of them should be synchronized successfully. Good. Okay, this is set to the server, so just wait for it to synchronize and we'll be back there. So if we get back to our access switch and if you check again, we realize that now our VLANs are all available here without you creating them. That's one of the powerful use of VTP, and it saves you time creating all these VLANs everywhere. So now, having that been done, we now need to make these two ports on this our access switch 1 to belong to VLAN 10. So I'll just do the int range, and we're just going to go there GI 0/1 to 2. Since they're all in order, I hit enter, and we'll do the switch port mode access and switch port access VLAN 10 here. And here we'll also make it to be switch port spanning tree. We'll take port fast. There's equally a protocol called BDU that actually helps to, in case let's say you set up spanning tree as we're about to do now, we'll say spanning tree port fast. So this tells this particular interface that, okay, it's always going to know that it's an endpoint device. You'll not try to use more time to set it up to be, to check if maybe there's another switch connected there. But what if another switch is connected there? So that's what BDU guard actually comes up to do. So in case another switch comes up, the interface just goes down to shut down. So it's a protective mechanism as well. So let's see. So we can be able to set up that after setting spanning tree port file, we can equally set up spanning tree video. Let's see, yes, this is it. Yeah. So BPD you got, we set it to enable like that. So when you set it to enable, in case another switch comes on these two interfaces, automatically the interface is shut down. It's a protective mechanism. So sometimes it's equally necessary for security purposes. Port fast equally helps to reduce latency as well. So having that been done here, we'll just take here do rmm. Those are the only configurations we need on those switches for now. So now here as well on our next switch here, I'll just take the do show VLAN brief if all our VLANs are here. Yes, they are here. We'll do the same thing. We'll just do the int range GI 0/1 to 2. We hit enter, and we will switch port mode access and switch port access VLAN 20. And I'll do spanning tree port fast, and we're equally going to do the spanning tree BPDU guard enable, take no shutdown. Take no shutdown there. Let's see, did we even take no shut here as well, or just take no shutdown here too? So we'll do that, and we'll go to our next VLAN here. Our next access switch, this is our sales switch access switch there. We'll check if our VLANs are here now. So our VLANs are back. Always give some little time. Sometimes if you within a lab environment, you can just go back to your core switch and then just try to check up the VCP status and then go back to your access switches and then you hold on for it. So now we'll go to our sales access switch, and here we'll just do the same thing. We'll do int range gi 0/1 to 2 as well, and we're going to do switch port mode access, switch port access VLAN 30, and do switch port mode, no, we'll do switch port spanning tree port fast. Hit enter, and we call it spanning tree BPDU guard. Then we need to use enable. Yes. So I'll do that. I'll take no shut down, and I'll take do right name to save our configurations. So this same process is what we do for all these other interfaces. If you want to give access, like for this other staff Wi-Fi here, you can do the same thing and the likes of that. So that's just a simulation as we have done for this three. You can proceed to do same for all the rest. It is just fine as well. So now, having that been done, the next thing now is just for us to test. So now we have not set up DHCP yet, but we are going to manually give an IP address to these devices here. And then after that, we are also going to set up a DHCP server here to see how the DHCP server can equally give out IP addresses to devices in this kind of environment. So if you have an environment like this, the same parameters apply. If you're running your domain controller, which is much necessary for you to be doing, you can set up your domain controller. But we are going to see how to set up things like probably DNS and Active Directory in this environment. So see how we can make it work here as well. So now to test, first of all, if there's connectivity true before going to all these other different protocols, the first thing that we are going to want to do is we are going to want to get to I'll come to this, our first client here. This is our PC27. I'll set it an IP, I'll give it an IP address in that network. So take IP add. So just IP, since it's just a test VPC, 192.168.10. I'll just give .10.10 for now, /24. And I'll give it this gateway, which is going to be what's at the level of SVI, 192.168.10.1. Hit enter there. And I'll take save. I'll also come to this other, for this HR VLAN here, I'll come to this PC28, 29 rather. So once we are here, I'm just going to put IP and we'll give it an IP address in this network here, 192.168.20.20.1. I'll just put 20.10/24 there, and I'll put the gateway 192.168.20.1. Hit enter there, and I'll save the configurations. Save. After doing that, we can just use that for the test now. So now to test here, I'll come back to PC27. We'll just do some basic tests here. To test here, we expect that, okay, can this device even be able to reach its own gateway, which is at the level of the core switch here? So try to ping, for instance, 192.168.10.1. Is that going through? So we can hit the gateway. What about this interface of this our core switch? Is that reachable? So I'll try to ping that, which is 192.168.254.2. Is it reachable? It's reachable. Okay, so that's nice. What about our router here? Can we reach our router interface, which is that .1? Is it reachable? So we can hit this router interface here. So what about the internet? Can we actually hit the internet? So I'll try to ping something like 8.8.8.8. So hit enter there. Good. And it shows us all the parameters we set at the level of nothing is going through. So that's really a good success right here. If you can at least succeed to get this stage, and you're really good. What about inter-VLAN routing? Is traffic able to leave from one VLAN and get to another VLAN? Here, we'll do the ping from, since we're currently here, we'll try to reach this our HR here, which is the IP address on our test client PC here is 192.168.20.10. Is that possible? Hit enter, and we're currently getting a timeout, and it's now reachable. So that's quite good. That's really a good signal that what we have done is quite good. Everything looks just fine like that. It shows everything we did looks fine. So the next thing now is, after understanding that the underlay traffic is moving fine and everything is going smoothly, we can then go to set up our DHCP server here, so that our DHCP server can give out IP addresses to all devices in the network that is available here. So now, to make that happen, here, what we are going to do is, I'm going to go to our DHCP server here. I'll just double click on it. You can double click on that. If you have your Zabbix server for network monitoring, you can monitor the network and the likes of that as well. If you have your web server hosted locally, even though this is not a prime design, because your DMZ network is equally a whole different agenda on its own, and there's no security in this lab, so it's just purely for networking and the likes of that. So I'll just expand our server here, so we can set this server up for connectivity. We'll just give it some time. And again, while it's coming up, the key thing I want us to understand here, just for concept's sake, is when traffic from here, let's say, is about to get to the internet, the pattern flow is it gets to this access switch. Since we made this interface to belong to VLAN 10, VLAN 10 is not connected to the internet, but because we trunk this interface, it's going to move here as well. So here, since all these other interface of these distribution switches are trunked, even here we trunk this and trunk this. If you look closely, since spanning tree is configured, automatically not trunking, especially when you have a loop like this, not all these interfaces, the traffic coming from within here is not just going to automatically go here and here as well on this side. Because remember that on these two links, what happened is we just did the switch port mode trunk. We never allowed some specific VLAN. So all VLAN traffic is going to be able to go through this interface and also these interfaces here. But on this particular interface at the bottom here, we specify that here we need just VLAN 20 traffic, we need just VLAN 30 traffic. When we did the switch port mode trunk, allowed VLAN 10. So if the destination is not VLAN 10, it will never come down through this interface of this distribution switch. So from this point here, since this is strong, it gets to, and this interface here permits all VLANs, so it gets here to the core switch. From the core switch looks at the destination. Where is this packet intended to go? Since it wants to reach the internet, then since we set a default route, that if this core switch does not know the destination, because this core switch knows all the other different networks that SVI has, because we set up SVI there. Since it does not know it, it then forwards it to this router as we set up the default route. And the router now, since here the router also has a default route to reach the internet, it gets there to the internet, and from there our internet service providers route the traffic through. But now upon return, once traffic is getting back, it gets back to our core, to our router here. In this router, we equally set a default route that if it receives packets where the destination is any of these our internal LANs that we have, then we told this router to forward it down to this our core switch. And within this core switch, because of SVI, the SVI is directly connected to all these networks here. So that's why it knows how to forward it through these our trunk ports here. It forwards it down through this trunk port or this other trunk port here. And once it does that, it gets to this distribution switch. If it sees that the tag on the traffic is, let's say, an ID of 20 or 10, which represents the different VLANs, then it forwards it down to the respective VLAN, to the respective port that allows, all of them are trunked, but the trunk port that allows VLAN 30 or 20 traffic is where it's going to forward it to, depending on the ID that is there. So that's how it works for traffic to go to the internet and out of the internet, to the internet and back rather. And same thing applies for inter-VLAN communication as well, where packets from here want to get to this destination, it gets here. From here, it does not just move down to the from here, since this is a different network, it does not just leave the distribution switch and then get down to this access switch here. The whole purpose for that is because since the IDs are not the same, you need the core switch, because the core switch is the one that has the ability to be able to forward the packets from one network to the next network, because it has the SVI gateways available there. So from there, it can be able to switch it through and then get back to the intended destination. So it's good to have that in mind like that. So I'll clear that, and we're going to go to our server here to set our DHCP server and the likes of that. So I'll just go back to our screen keyboard here, Control Alt Del, and put in our password. You can set up Active Directory and the likes of that. I'll just put in our password that we need to put from here and wait for it to come up. So remember that this is our server, and on this port here, we make this port to belong to VLAN 99. And the gateway for VLAN 99 is 192.168.1.1 on the core switch. We can check that again at the level of our core switch here, where if I take a connect and I'll hit enter here, and if I take enable and show IP interface brief, we'll see clearly that for VLAN 99, this is their gateway here. So any device that has access to VLAN 99, this is VLAN 99 here, the access, we must make sure that since we already set up this port to be an access port for VLAN 99, we just need to make sure it gets an IP address in that network. So we'll go to our DHCP server here, and first thing first, we want to go to local servers and set up our IP address. So now to do that, currently we'll have a different IP address here. I'll click on this, or I click here, and then we'll go to properties here. So when this comes, we'll go to IPv4, and I'm going to also set this up here. We'll set the IP up as 192.168. Set it up as 192.168.10.99 rather .10. The subnet mask maintains. The gateway needs to be set 192.168.99.1 as what is on the SVI gateway. So this is going to be the DNS server itself. I'll just put here the DNS 192.168.99.1. 10. This is going to be its own DNS server. So just hit OK and the likes of that. And then once you do that, I'll equally hit OK. So once that is done, the next thing we want to do is we want to just set up our DNS server here. I'll just take yes. So by the way, taking yes, you need to be careful of for that in production. You're just simply making this your network accessible for file shares and the likes of that within the environment. So it's good to be careful as well. So I'll close this. And while we're here, we'll try to bring in add new roles and features. You click on manage, you go to add new roles and features. I'll just take next as well. I'll click on next. And here we're just going to, if you want Active Directory, you can click whatever service you need. We'll just put DHCP, I'll take add feature, and I'll put DNS here as well, add feature, and I'll take next. Just take next, click next again, click next, and here we'll install these two services that we need. Once the installation is done, we'll just set it up as well. So once that is done, we'll just close this, and then from there, if we go to if you come here to tools, you see that we have DHCP already set up here like that. And when that is done, we'll have the DHCP tool available here, so you can click on DHCP. So I'll click DHCP first. Once it comes up, we just create our different scopes and just set it up to see how we can make it work in this basic network environment. So once it's back, you can all clearly see that we are connected to the internet here. And to prove that we're connected to the internet, we can just try to see how to ping that. Let's say, for instance, if you ping, for instance, 8.8.8.8, let's say 8. Oh, I think I needed a ping. If you do the ping, for instance, you expect this to go through, and it's going through quite all right. But if you open your browser, for instance, let's just say I open Firefox. This is the browser I currently have in this environment. If you open the browser in this environment and you try to hit something like, maybe, let's see if we have DNS automatically gotten from here first. I'll try to IP config /all. I just want to see if we have IP we take IP config /all. I just want to check and see if we have DNS automatically gotten from this environment. We'll just give it some time. So in the case where you set up, probably you set your IP addresses up and DNS server is set up as well. Even though you have internet access, but you need to make sure the DNS server is set probably to 8.8.8 or whatever DNS server you have available. So we'll just go ahead to set up DHCP here at least, and then from there we'll see how to make it happen. So from here, we'll hit the drop down arrow for Adobe Tech. We're setting up IP addresses for IPv4. So I'll just hit the drop down arrow here as well here, and I'll right click on that on IPv4. We'll take new scope. Remember, we have, based on this environment, we'll just set up these 3 different networks. So since you have different networks, you have to create different scopes for those different networks. So in this environment, we'll just create 3 scopes for our 3 networks. So now here, I'll just take next. When I take that, I'll click on next. And once you do that, I'll just give it a name, as I'll just say it's probably scope 1. Take next. And when this comes up, you can just do the exclusions from here directly. You can say anybody who wants an IP address, start giving them IP addresses from 192.168, 192.168.10. That's for the .10 network. Let's say from that, we just say start from .10. Maybe I'll just put 50. Your subnetting plan has to be good to match the number of users in your environment and the likes of that. And then we'll say the last IP address should be 192.168.10. Let's 240 for instance. I'll just take that and make sure the subnet max matches. I'll take next here. Once you take next, if you want to exclude some other IP addresses, but if you realize from our previous setup here, we did the exclusion already, because from 1 to 50, from 1 to 49, those IP addresses are normally excluded. So did the exclusions there, no need to do it here as well. You can do it if you want to, or go ahead to click next. Let me see, I hope I've not missed the gateway. Yes, okay. So we'll leave the least duration like this. For DHCP, yes, I want to configure this now. Now, for the gateway here, it's important. Router default gateway. Anybody who receives an IP address in this network, what should be their gateway? It should be 192. It should be 192.168.10.1. That is the SVI interface. You take add. You take next. You take next. And for DNS servers, if you had DNS, you normally set it up there. If you had Win servers, you do that. But for this, we'll just keep the default. Just take next as well, and you take finish. So that's going to be it there. DHCP is set like that for that already. So I've just created one scope. You can go ahead to make this video not too long. You can go ahead and right click here and add another scope again if you want to. But now we have created just one scope. You can create another one here. We have created one scope, which is, if I hit this drop down arrow here for scope, let me double click on this so we can all see it here. Yes, so you can see within this scope we have the address pool, the address list, reservations, scope, options, and the likes of that. So currently right now we have created just one particular scope, which is scope 1. Let me expand this so you can see it. So we have just one particular scope, which is the scope 1 for this network here. So but now you realize that if we come to this our PC here, is in one, these devices are supposed to be in the 192.168.10 network. So if we go there to, I think it's 27, that's PC 27, I'll click on 27. So I'll reconnect this. If I put IP at probably IP DHCP. So if you take IP DHCP, realize that we are unable to reach the DHCP server here. And this is normally normal because whenever your DHCP server is not in the same network as the DHCP clients, then whatever is in between that network has to act like the relay, the IP helper, the DHCP helper rather. It needs to help these clients, it needs to help the request from these clients to receive an IP address to make sure the server receives those requests. So now if we go to our core switch again here, we realize that I hit enable here. We type in enable. Let me move this better. We type enable. We'll go to the, if you take show IP interface brief. You realize that we have our different VLANs and all of their, these are the different SVIs here. So you see that traffic from VLAN 10 is normally going to hit this SVI here, and this SVI is like the main guy that needs to help traffic that's coming from the different VLANs there to get to it. So we need to make sure that we'll go to the configuration terminal, conf t, and once we do that, then we are going to then need to go to int VLAN 99, and here we'll do IP helper. We'll do IP helper address, and we'll put the IP address of the DHCP server 192.168. See, IP helper address, which should be 192.168.10, sorry, .99.10. So we need this to be here as well. So we'll go back again to our clients and check if I use IP DHCP here. Is that possible? They are still failing, or let's see, this time around it fails. We'll try again. Definitely, I think it should be on the interface that is for IP DHCP. Let me try that one more time. All right, if that fails, let's see, I believe it should be, let me exit this. I'll exit this, and I'll go to, since it's for VLAN 10, I'll go to int VLAN 10, and I'll do the same thing, int VLAN 10, and we'll do the IP helper address. We'll put this, we're just going to put this address here, IP helper address 192.168.99.10. that needs to be there, and if all goes well, it should work. Let's see, IP DHCP, yes, that's good. So now the client receives an IP address. So to explain what we've just done here right now, coming back to our core switch, you realize that this VLAN interface here is always going to be the one that is going to receive the request, and the switch is directly also connected to the server here. So once we tell this interface that you need to help clients that are requesting for anybody, that if you receive DHCP broadcast signals through this interface, then you should know that there's a possibility for you to help them reach where the DHCP server is, which is this network where you're directly connected to. So in effect, you don't need to set it up on this interface. You need to set it up on the VLAN 10 interface. So similarly, if you want devices in VLAN 20 to receive an IP address from the DHCP server, you need to equally enter this interface and do the IP helper address and put the IP address of the server. So now you need to also make sure that the scope for VLAN 20 is accessible. So if you go to this device here and I do show IP, for instance, you can see clearly that it has gotten an IP and equally knows its DNS server and the likes of that. So if we do, for instance, we do a ping, for instance, to 8.8.8. So 8.8.8. We are able to reach the internet and the likes of that. And also, if we just try to trace the path, if we just use the command trace, and you put, let's say, 8.8.8.8, you realize that for it to be able to reach this Google DNS, this Google IP address here, first thing is that it had to first of all hit the gateway at the level of the core switch. From the core switch, you realize this is the IP address of the router, that's the next hop. And after this, it hit this NISP gateway in our environment. Then from there, we'll have our public IP addresses, which are over the internet, and it had to go through all of these paths before finally targeting the final destination. So it's good to know. What if we do a trace to the other destination here? Let's see the path. How is it able to be able to get, let's say, the traffic from here is destined for this other HR device here. Remember, the IP address was 192.168.20.10. We'll do the trace, and we'll remove that 192.168 .20.10. You see the path. Realize that it's so simple. It just first of all gets to just this. It gets to the gateway, and that's it there. So if we do a ping, for instance, I'll just do a ping to that, and let's see. Let me do a trace one more time. Let's do a ping to that destination. I'll do a ping to 192.168.20.10. Yes, it's reachable. So you can see that first of all, it has to always first of all go through the SVI gateway. Then from there, since the gateway is connected to it, it reaches it automatically. So that's how it normally works. And hopefully there's some key things we've learned in this environment. If you have your access point, the same thing applies, setting up them and likes of that. So with that being said, don't forget to like, share, and subscribe. And I look forward to seeing you guys in more videos. And if you want to learn more cool concepts like this and make them work, you can head over to www.dobrytech.com. There you can get enrolled and you see how to be able to improve your networking skills and equally your security skills as well in this space. So I look forward to seeing you guys in the next video. So don't forget to like, share, and subscribe. See you next time.